Welcome back, everyone. This week we are going to continue to talk about linear equations. We're going to focus on graphing linear equations. It's important that you read through this page and understand what it is talking about. Look at the objectives, the vocabulary, and then read about linear equations, ordered pairs, and what a table is. And then on the next page, it's going to be important for you to read through this so that you can understand how to identify a linear equation. And the key really is in the helpful hint in the bottom green box where it says the exponent on the x and y in linear equations is always 1. So that's kind of the key hint that you can use to identify a linear equation. Okay, so first example, we are going to be graphing linear equations using a table. In this case, we have the table for us, and we have some numbers that are already in the table. What we have to do is complete the table of ordered pairs and then use those ordered pairs to be able to graph this linear equation. So in this case, since we have x minus y equals 4, we have both x's and y's in the table because we can plug in either one and it's relatively easy to solve for the other. So in the first one, we have x is 0, so we can plug in 0. So we have 0 minus y equals 4. So we end up with negative y equals 4, and then to get rid of the negative, we just divide by negative 1, so y is negative 4. So we're going to go ahead and put negative 4 in our table. And then the second one, we have y is 2, so you can see how it's going to be kind of easy to do either one here. So we have x minus 2 equals 4, and then we'll add 2 to both sides to get x equals 6. So we'll go ahead and fill that in the table for x. And then the last one, we have x is negative 1, so we have negative 1 minus y equals 4. And we'll add 1 to both sides, so we end up with negative y equals 5. And then just like the first one, we're going to divide by negative 1 to get y is negative 5. So we're going to go ahead and plug that in. Okay, so we have a table of 3 ordered pairs. They're x and y values, and we can go ahead and graph this. So I'm going to go ahead and draw a graph that we can plot our line on. And we have an x and y axis. So this is the x, this is the y. And we have a scale that we're going to need to go up to 6 on the x-axis. And we're going to need to be able to go down to negative 5 on the y-axis. So if we just put a bunch of marks on here, 1, 2, 3, 4, 5, 6, and we'll try and do them about the same size. And I'm going to go, so let's see here, do I need to go positive? Yeah, I need to go up to positive 2 here, and then I need to go to negative 1 here, so I'll just put that 1 there. So I can go ahead and plot my points. So I have 0, negative 4, so I'm going to start at 0 on the x-axis and then go down to negative 4. So we have 1, 2, 3, 4, so it's right about here, I think. There we go. And then we have 6, 2, so we're going to go over to 6 on the x-axis and then up to 2. And then we have negative 1, negative 5, so we're going to go negative 1 on the x-axis and then down to negative 5. And you can see that those 3 red dots are pretty much in a straight line, and it's not going to be possible to necessarily get them perfect when you're drawing your graphs by hand, but this is considered close enough, and so we can connect those 3 dots, and I'm going to put arrowheads on either end because the arrowheads represent that line continues on forever. Okay, so the next example is y equals 1/3 x plus 2, and there's no table with this one. And in this example, it's going to be easier to plug in the x value than it is the y value. So we'll go ahead and create a table of x's and y's. And in this case, we can pick any x value we want. We can pick positive, we can pick negative. I like to pick positive numbers if I can. I always like to pick 0 because 0 is easy to work with. And then in this case, since we have a 1/3 x, we want to pick x values that are divisible by 3 so that we get nice, neat numbers. So I'm going to do 0, 3, and 6. Okay, so when I plug those in, I have y equals 1/3 times 0 plus 2. Well, the 1/3 times 0 just goes away, so that's y is equal to 2. And then for the second one, I have y is equal to 1/3 times 3 plus 2. And 1/3 times 3, if we think about it, it's the same as just saying, well, what's 1/3 of 3? Well, that's 1. So we have y equals 1 plus 2, or y equals 3. So I can plug that into my table. And then the last one, y equals 6. So I have x equals 6, 1/3 times 6 plus 2. And if we think in terms of the same thing, 1/3 of 6 is 2. So we have y equals 2 plus 2. Or y is equal to 4. Okay, so same thing, I can create a graph to graph this thing. We have x values, we have y values. I need to go up to 6 on the x-axis. It's all positive, so I have 1, 2, 3, 4, 5, 6. And then I am all positive on the y values too, and I need to go up to 4. So 1, 2, 3, 4. Okay, so everything is going to be in what's called the first quadrant, because everything is positive. So I'm going to go ahead and graph this. And I'm going to start by plotting the point 0, 2. So I go to 0 and up to 2. And then I have 3, 3. So I go over to 3 and up to 3. And then I have 6 and 4. Okay, so we just are close to where we need to be. And we can see that those 3 points end up looking like they're on a line. So I'm going to go ahead and connect them and add the arrowheads to either end. Okay, so this was a good example of an equation that's in slope-intercept form, and it's much easier to use x values to figure out the y values than it is to use y values to figure out the x values. So something to consider. In this one, it's an equation that's in standard form, and what we need to do is, again, just create a table. So I'm going to create a table here, x and y values. And this one is a little trickier because we need to figure out what numbers to put in here. And it's kind of a game of trial and error, because you might plug in a number and you end up getting a weird fraction of some sort. But one number I always like to start with is 0. So I'm going to try 0. And then I might try something like, I'm going to go out of order here, and that's okay. I'm going to try -1 and 1, just because those are simple as well. Now, there's no guarantee that either of these are going to work. When I say work, what I mean is come out to a nice, neat integer as a y value. It might be a fraction of some sort, and that's okay. We can deal with fractions. So notice how I'm using all x values here. I could have picked some y values. It would have been about the same, but I just went with the x values to make it a little simpler here. So the first one, we have x is 0, so we have -5 times 0 plus 3y equals 15. So that means that -5 times 0 goes away, so we have 3y equals 15. And when we divide by 3, y is 5. So I can go ahead and plug 5 in. So there, that's a nice, neat one we can work with. The next one, we have -1. So we're going to plug in -1 for x. So we have -5 times -1 plus 3y equals 15. My handwriting is a little sloppy here. So -5 times -1 is +5. And then we're going to subtract 5 from both sides, so we end up with 3y equals 10. And then we divide by 3, so y is equal to 10/3, which is a fraction. And we could put that fraction in the table if we want, but it's kind of hard to see where a fraction goes on a graph. But if we just grab a calculator and do 10 divided by 3, we end up with 3.33. So I'm going to go ahead and put 3.33 in the table. Okay, so that 3.33, I can visualize where that is on a graph, whereas the 10/3 I can't. So the last one, I'm going to need to move this over a little bit, I think. Yeah, there we go. All right, so the last one, we have +1, so I have -5 times 1 plus 3y equals 15. So we have -5 plus 3y equals 15, and then we're going to add 5 to both sides, so we have 3y equals 20. Divided by 3y is 20/3. So again, we have a funky fraction that we have to deal with. So if we just divide 20 by 3, we end up with 6.67. So I'm going to go ahead and put that in the table. Okay, and 6.67 is something I can visualize on a graph. So when I go ahead to graph this thing, I have x and y values. And I need to go from -1 to 1 on the x-axis, and then I need to go all positive up to 6.67. So I'm going to go up to like 1, 2, 3, 4, 5, 6, 7, way up there. So here I'm going to move that. Whoops, here we go. There we go. So the first number we want to graph is 0, 5. So we're going to go 0 and then all the way up to 5. 1, 2, 3, 4, 5. Okay, and then we have -1, 3.33. So this is one where we have to just kind of guess. So we go up to 3 and then we go about 1/3 of the way between 3 and 4. So we're going to be somewhere about right there. And then the other one we have 6.67. So we're going to start at 1 and go up to 6.67. So we have 1, 2, 3, 4, 5, 6. So it's going to be about right there. So you can see that they end up looking like they're on a straight line. Now, if one of these was way off somewhere, if it was way off over here to the right or the left, you would want to then recheck your math when you did your calculations for your ordered pair. But in this case, they look good. So I can go ahead and connect them and put arrowheads on either end. All right, last thing we need to talk about is we have 2 special cases that we have to deal with. And I think it's going to be easiest just to show you on the graph. So I'm going to go ahead and graph these right away. Okay, so we have x and y values. And in this case, it says x is equal to -5. So you'll notice there's no y. So what that means is no matter what value of y we pick, x is always going to be -5. Okay, so I'm going to go ahead and put -5 on the graph here. And so then, like, if I pick, let's say I pick y is 3. Well, I know I'm going to be at -5 here. Well, let's say I pick y is -6. I know I'm going to be at x is equal to -5 because it's telling me that x is equal to -5. And it doesn't matter what y value I plug in here. X is always equal to -5. Okay, so I can just go ahead and connect those 2 dots. And what we end up with, that's got to be a little neater. What we end up with when we, whoops, I don't want to erase that. Let's do that again. Okay, what we end up with when we graph x equals -5 is we end up with a vertical line. Okay, it's kind of the opposite of what we would think because the x-axis is horizontal, but we end up with a vertical line. And you might guess that with y equals, we're going to end up with the opposite. We're going to end up with a horizontal line. So same thing, no matter what value of x I pick, so I could pick x is 4, I could pick x is -7, y is always going to be 2. So I'm going to plot my points like that, and then I can just draw a horizontal line. So when you have y equals, it ends up being a horizontal line. All right, that's it for graphing using ordered pairs and tables. So go ahead and try the assignment. When you're done, submit it on Schoology, and I'll take a look at it for you.